Hello students, in annual examination 100% choice is there for asking for 4 marks. Let's concentrate all of you. In thermodynamics they are asking this question: obtain an expression for the work done. What we are finding? Work done by an ideal gas during isothermal change, are also called as isothermal process. So what is the mean of isothermal change or isothermal process? In process, actually this thermodynamics depends on 4 variables. What is that? Pressure, volume, temperature, number of moles of ideal gases. So in this isothermal process, temperature is constant, remaining terms are changes, remaining variables are changes, pressure also changes, volume also changes. So the process in which thermodynamic system undergoes the changes at constant temperature is constant, is called as isothermal process. The process in this isothermal process, in ideal gas, the gas laws are obeys Boyle's law as well as Charles law, but in this temperature is constant means in this process it will be obeys, it will be represented the Boyle's law. So in Boyle's law also temperature is constant. Temperature is constant is nothing but pressure into volume is equal to constant. PV is equal to constant. The term is what, sir? PV is equal to K. Now how the work is done in isothermal process? See, let's concentrate here. You already know, already we are seeing in previous classes. So if the gas is expand, let's consider 1 mole ideal gas contained in a cylinder and the amount of heat energy is supplied to the system, automatically gas is expands through a small volume dV at constant temperature. So work is done by the gas in isothermal processes. You already know the formula of that. W is equal to P into dV. W is equal to P into dV. So the amount of heat energy at constant, it changing the volume V1 to V2. So what is the formula? W is equal to integral P into dV in between V1 to V2, integrating on both sides. Here we are finding the pressure from isothermal process from this equation, sir. So what is that value? P, according to ideal gas equation, what is the formula of ideal gas equation? PV is equal to RT at 1 mole. From this, P is equal to what? RT by V. So replace of P, we are writing the RT by V into dV. So RT, R is a constant, universal gas constant, and temperature is constant in isothermal process. That's why we are taken to the outside of the constant. Remaining term is 1 by V into dV. Sir, integral 1 by V into dV using the formula of integral 1 by x into dx is equal to log x. Same as here we are applying this formula. W is equal to RT of 1 by V into dV is nothing but log V in between the V1 and V2. V1 and V2 volumes. W is equal to RT of, you already know in logarithmic table, logarithmic process, log V2 minus log V1, log V into V2 minus log V1, log A minus log B, using which formula? Log A minus log B. So log A by B, log of V2 by V1. So easily we can find the value of log E. Log E value is in logarithmic table 2.303 log of 10 base 10 V2 by V1. So our work done in isothermal process is what, sir? W is equal to 2.303 RT log of V2 by V1. As P1 V1 is equal to P2 V2 is nothing but replace of V2 by V1, we will write the P1 by P2. Thank you. Yes, in this question also we have to be seen same like that only, but process is changed. What is that? Adiabatic process. So this question also very important for 4 marks. Obtain an expression for the work done by an ideal gas during adiabatic change or adiabatic process. So what will happening in this adiabatic process? Sir, in this process, a process in which undergoes changes in pressure and volume, so that no exchange of heat between the gas and the surroundings and the system takes place is called adiabatic change. Means what we'll get? Sir, in this total variables are changes, but no heat flow from system to surrounding and surrounding to system. This process is called as adiabatic process or adiabatic change. So in this adiabatic process, work done in adiabatic process, for an adiabatic process that follows, that obeys the PV power gamma is equal to K. K is nothing but constant. You already know, same as it is in isothermal process also, if W is the work done during adiabatic process. So if the gas is expanded through small volume dV, work done by the gas is dW is equal to P into dV. The work done in adiabatic process of an ideal gas from the state P1 changes from P1 to P2, V1 to V2, T1 to T2. Then amount of work done has to be changes, then integrating on both sides. dW is integrating means derivative integral is cancelled directly, we are taken W is equal to integral P into dV of V1 to V2. So how could you take the value of this from this? PV power gamma is nothing but from that P is equal to K by V power gamma. So we are directly taken to the value of K into V power minus gamma. Like this also we are taken. So replace of P we are substituting this value 1 by V power gamma. K is constant, that's why we are taken to the outside of the integral. You already know, sir, this term is taken to upside means V power integral V1 to V2 V power minus gamma into dV. So this is the formula. Using this integration formula is what, sir? X power n into dx is equal to x power n plus 1 by n plus 1. Use this formula, we can easily finding the answer. V power minus gamma plus 1 by minus gamma plus 1. So see, this term is taken to outside, then what will happen? Minus gamma plus 1. Here we are taken 1 by V2. Substitute this value in this equation. V2 power gamma minus 1 minus by V1 power gamma minus 1. We already know from the adiabatic process, pressure changes, volume changes. P1 V1 power gamma is equal to P2 V2 power gamma is equal to constant. Replace of V2 we are taken, replace of K we are taken to the value of P2 V2 by V2 power gamma minus 1 minus P1 V1 by V1 power gamma minus 1. So how could you take from ideal gas equation PV is equal to RT? So from this PR T is equal to, how could you take PV by R? So what is the value of T2 then? T2 is equal to P2 V2 by V2 minus P1 V1 by V1. So P2 V2 minus P1 V1 according to ideal gas equation. Easily we can find the value. P2 V2 is equal to what, sir? RT2. RT2 from ideal gas equation. P1 V1 is nothing but RT1. R is common, so remaining term is what? T2 minus T1. R we are taken to work done in an adiabatic process at n mole ideal gas, nr by this term is goes to that side means gamma minus 1. We are taken to the minus is common, then we will get the temperature T1 minus T2. So here easily we can find W work done in adiabatic process nr by gamma minus 1 into T1 minus T2. So thank you.